Some people have asked me, why am I focused on 8-bit microcontrollers? Why not 32-bit and all the latest stuff? I'm not against any of that. It's just there's already all kinds of videos covering that. But I couldn't find enough covering 8-bit microcontrollers, which is really what I love. And also, I love programming in a simple, basic language because that's where I started with old computers like this. Yeah, I'm that old. So there's a reason I'm doing it, and it's adding another tool to your toolbox, which I think is something everyone should know. So let me explain how I got here and why I still like 8-bit on today's Chuck Hellebuyck's Electronic Products. When I started this channel almost 13 years ago, 8-bit microcontrollers were still really popular, but there were 32-bit that were released. They were just a lot more expensive, and some of the hobbyist modules weren't around yet where you could get them for a few bucks. And most of the tools that we were using back then, such as a desktop CNC or a Ender 3 3D printer, they both ran on 8-bit. The CNCs, a lot of them still do have an 8-bit microcontroller in it, but these ran basically, both of them, on 8-bit Arduino code. This started out with Gerbil and still kind of uses it. This runs on Marlin, which was Gerbil code with some stuff added to it to run the 3D printer. That was the firmware that ran the 8-bit machines. And Gerbil is the one that ran these 8-bit machines. And what was really cool back then is both of these 8-bit applications also allowed mechanical people, electrical people, software people, all to work together to make these machines better. The mechanical structure, how the hot end worked, and all the motors and gearing, that was the mechanical. And then you had the electronics, how the hot end was wired, how the LCD worked, electrical, and then you had the firmware. And it was kind of the same thing here. You had a control board that controlled the motor, that would actually control the stepper motors, mechanical, with the Gerbil firmware, and then you would write G code to control this thing. And we all worked together and learned how to make these things better, and that was the fun. And it was also mostly open source. And all that drastically changed about 3 years ago when Bamboo Labs came out with their printers. It changed the whole 3D printing market because now you could take a printer out of the box, it worked really well, and you could just start printing. You didn't have to build anything. In fact, it shifted things. Ender 3 has gone away, and now all you see in enclosed printers. Even Prusa went from an open bed slinger to their enclosed printers, and I love these things back here. They're my favorite printers. And so it changed. And so people kind of said, shove 8-bit aside, because now you're running Clipper, which has a 32-bit, talking to a 32-bit board on the machine, and then there's even sensors in the hot ends. I mean, there's so much electronics on these machines now, it's incredible. But there's still applications where 8-bit little sensors and things work really well. And I love the fact that these can still be used. I can still 3D print on an Ender 3. Takes a little longer, but I can get good quality out of it. I can still cut circuit boards on a CNC, desktop CNC like this. I mean, there's a circuit board that was cut right here. I'm always playing with these tools because I still love 8-bit and what it could do, and tinkering. But I don't want to claim that 8-bit is going to, make a comeback, or 32-bit isn't taking over, because in many ways it is. But again, having more tools in your toolbox, I'm telling you, it's worth having, because eventually you're going to lose what the 8-bit and even the analog chips and stuff could do, and you got to try to do it all in code, and you can't do it all in code. You can't. So you need to understand hardware. And that, to me, is where the 8-bit stuff comes in. It's a great way to learn basic programming, but really focus on hardware and how it works. Now, someone could easily claim that I'm an old man and it's old school and I need to catch up with the times. But the thing is, programming a microcontroller in a DIP package is getting harder to find because 32-bit is mostly surface mount. In fact, there's many 8-bit microcontrollers now that you can't even get in a DIP package, like some of the ATTINYs. You just can't get in a DIP package. And this makes it easier to build in a breadboard or solder together on a board, especially when you're just learning electronics. So the easier it is to start, the easier it is to grasp, and then you can grow from there. And just to validate the fact that, yeah, I'm an old man, I was around before microcontrollers existed. I was doing electronics as a kid before we had microprocessors or microcontrollers. They came out about 1975 to where we could kind of afford them or just start to afford them. By that point, I was 14 years old and already fooling with Radio Shack kits and stuff. My first computer was a VIC-20. I got this in college. I was learning to program BASIC in high school on a teletype machine, but my first home computer was this guy, which is based on a 6502 8-bit microcontroller. So I learned how to program on this using the language BASIC. And then I found out there's an expansion port on the back where I could get to the I/O pins, those pins on the IC. So I could connect boards to this, and I programmed this to send signals to a speech chip, and I got this thing to talk. And several other things that I could control from my VIC-20. But what I really wanted to do is once I programmed it, I wanted to be able to take the chip out of it and build it into an electronic product. So take the chip out of this thing, build it into a circuit board, and make a talking module or whatever I came up with the code inside the microcontroller. And that was really hard to do back then. So I started working with my own PIC microcontrollers years ago to make my own modules. I was trying to build an Arduino. I wasn't too successful, but then Arduino came out, and so they used an AVR microcontroller, which was from a different company than PIC. So I designed the CHIPINO so I could use shields and still use the same microcontrollers I was familiar with. Of course, later on, I learned Arduino, so now I could do both. But I never left BASIC. I'm not a great programmer, and so I really still love BASIC, and it's the beginner's all-purpose symbolic instruction code, BASIC. So it's for beginners, and it's real easy to learn. And so I was always looking for a basic language compiler, and I didn't have one for Arduino, but it turns out there were some basic language compilers for PICs. So I could use it with CHIPINO. In fact, my favorite turned out to be GCBASIC, which originally was called Great Cow Basic, and it was developed back, my God, 25 years ago, I think, by a guy in Australia, Hugh Considine. And he also, at one point, made that same compiler work for both PIC and AVR. So now you can program either one of these in GCBASIC. But here's the thing. Unlike the BASIC that ran on these, which was interpreted and slow, GCBASIC is a compiler. So it produces pure assembly code, which many will call bare metal programming. So you're getting down to the registers, controlling what's going on inside that chip much faster and easier than this thing could ever do. And that's why I use it. And the best of all, it's free. You can download GCBASIC for free, and it's been updated many, many times, and it produces that pure assembly code. In fact, it's more efficient code than what Arduino uses, because Arduino uses like a C++, which is a higher level language with libraries and stuff, which makes a lot of extra bloatware. And you can program this in Arduino closer to the bare metal level, but it's a little more difficult. And that's why I love my CHIPINO, because I go right down to that assembly language level and get down to the ones and zeros, and I can really control what's going on. Being able to understand that is a bonus. That's not something you're ever going to learn with 32-bit, or probably never learn with 32-bit. So that's another reason why I recommend people play with 8-bit microcontrollers. And if you're not a coder like me, you can use a very similar BASIC to what you used many years ago. And the fact that the GCBASIC compiler can program both AVR or Arduino and PIC, CHIPINO, is awesome. And that means that those old Ender 3 boards like this that are 8-bit, they'd make great robotics boards because they got motor drivers on them, they've got sensor inputs. So if you want to get into robotics and 3D print your frame into different pieces, you can control it with an old Creality board that came out of an Ender 3. And then there's other things I'd like to do, like this board and PICkit combination was a starter kit years ago. And they discontinued the PICKIT2, but because it's open source, it lives on. The board itself Well, it's not really open source, but they showed the schematic and the top layer of the board in their documentation. So I actually reproduced this, and at some point I'll share that. And open source is great when you want to make your own circuit boards at PCBWay.com. PCBWay.com offers 10 boards for $5. It's a great deal. All you got to do is design your circuit boards, upload the Gerber files, tell them what details you want, the quantity, and you get an instant quote right on the side over here. So it's $5 plus shipping. So in my case, it's about $27 to get those boards. And if you want it assembled, they offer turnkey, kitted, or combo of the two. So they'll actually build the board for you with their low-cost assembly services. So if you're looking for this type of service, check out PCBWay.com. And that's what I used in my C book, because I did eventually learn C. And I wrote some books about it. And again, another tool in my toolbox. I still prefer the simplicity of BASIC and the GCBASIC compiler, because the C, you kind of learn the different version of C, although now Microchip bought Atmel, so now AVR and PIC have combined and you can use their latest compilers. So if you want the latest and greatest tools, you're prepared. So everything I'm showing you here, and I plan to show in future videos, is to give you the groundwork that you can build from there. And if you want to just do hobbyist stuff and do simple stuff with 8-bit, go for it. If you want to advance and do 32-bit or combine the two, some 8-bit, some 32-bit, go for it. It's just learning the hardware and the basics of programming the hardware is what I'm trying to portray. And my niche is mostly the PIC stuff. I know the PIC microcontrollers like the back of my hand. And using these simple tools, I hope to have a lot of fun, and I hope you guys enjoy it. So that's why I love the 8-bit. It's been with me a long time, from the early days of programming this. So right now, as I do less 3D printing because you don't need as much help with those things anymore, I want to get into other projects that involve 3D printing, CNC, and electronics. I want to give a special shout out to my Patreon supporters. With your support, you make these videos possible. Thanks for watching. If you like what I'm doing here, maybe check out some of the other videos popping up. If you want to help support the channel, Patreon is the best way to do it. And if nothing else, click on that CHEP logo and subscribe. I'll see you next time right here at Hellebuyck's Electronic Products and Filament Friday.